Okay, a few questions here about implied domains and simultaneous equations as part of it as well. So let's see if we can give it a go. So the first question says the function has the rule f of x equals a on x plus b such that f of 1 equals 3 on 2 and f of 2 equals 9. Find the values of a and b. Well, this first piece of information says that when x is 1, the whole function equals 3 on 2. We can say 3 on 2 equals a on 1 plus b. So that's equation 1. And the second equation says that when the whole function is equal to 9, x is 2. So we've got 9 equals a on 2 um, plus b. Okay. We can solve this by hand or we can use a calculator. So if we were to solve it by hand, we would use elimination or substitution, and we would just rearrange this top equation to get a or b as the subject, substitute it into here, solve for that variable, and then sub that in to the other equation to find the other variables. So, but we can also use a calculator. So it's good to know how to use our calculator. So let's do this. You're going to go keyboard, going to click this button here. All right, so the first one is 3 on 2 equals a on 1 is just a plus b, and then 9 equals a on 2 plus b. And we're solving for a and b, so we get a equals negative 15. Yep, so we get a equals negative 15 and b equals 16.5. A equals negative 15 and b equals 16.5. Is that right? Let me check. Yep. Okay, 16.5. Let's get that as a fractions better. 33 on 2. Okay, state the implied domain of f. All right, so we know the rule for f of x now is negative 15 on x uh, plus 33 on 2, just substituting in a and b into our function here. Okay, the implied domain. Now think about what the graph would look like. So we can graph it in a moment, but a graph is going to look like, and just in terms of the domain, it's going to have an asymptote at x equals 0. And hopefully you can realize why that would be the case, because x cannot be equal to 0 here. So you're going to get some sort of graph that has a vertical asymptote at x equals 0, and it's been shifted up 33 on 2. So it's been shifted up here. And there's been a reflection. So ordinarily it'd be in this axis in this one, but now it's going to be here and here. Anyway, the point is that the domain is going to be x is an element of all real numbers. It can be any number, not including 0. Alternatively, you could say x is an element of negative infinity to 0, not including 0, in union with 0 to infinity. So that would be your answer for that. I think that looks good. Okay, next one. Given that f of x equals a x plus b and f of 5 equals 10 and f of 1 equals negative 2, find the values of a and b. Okay, so again, when x is 5, so a times 5 plus b equals 10. That's equation 1. And equation 2 is when x is 1, the whole thing is negative 2. So a times 1 plus b equals negative 2. It's equation 2. Okay, so this is 5a plus b equals 10. And this is a plus b equals negative 2. Okay, let's actually just do this one by hand because why not? It's not too tricky. What we can say is we can say that a, if we just rearrange this equation, we're going to get negative 2 minus b. Okay, then substitute that into 1. So sub into 1. Okay, so wherever we see an a, we're going to put negative 2 minus b. So 5 times negative 2 minus b plus b equals 10. Now we can solve for b. So we're going to get negative 10 minus 5b plus b equals 10. Okay, minus 5b plus b is minus 4b. Add 10 to both sides gives you 20. So b equals negative 5. And therefore, we remember that a plus b, but b is negative 5 equals negative 2. So just using the equation here, a plus b equals negative 2, but if b is negative 5, so a plus negative 5 equals negative 2. So we're going to add 5 to both sides. So we're going to get a equals negative 2 plus 5, which is 3. And so find the values of a and b. Yeah, we found them. That's b, and that's a. Should we check? Let's check that we got that right. So what we can do is we do the same thing we did before. So we've got a times x plus b. Oh, let's do it. Let's do it the full way. So let's define a function, which is f of x. So ax plus b. Do it like this: a times x plus b. Interactive, advanced, not advanced, define rather. F of x, define that as f of x. Okay, and then we're going to say f of 5 equals 10, and f of 1 equals negative 2, and we want to solve, remember f is in terms of a and b, so we're going to solve for a and b. And we get a equals 3 and b equals negative 5, so we know we got it right. So we can do a sanity check with our calculator there. Okay, next one. This is a bunch of questions all at once, so let's see if we can make some sense of them. State the implied maximal domain for each of the following. Okay, so we need to think about what these graphs look like. And maybe what we can do is we can sketch them on the calculator. So this first one, A. Okay, looking at it, we've got y equals 1 on x minus 2. Clearly, we can't have x being equal to 2, because if x is equal to 2, we're dividing by 0. Remember, x is our domain, so that's all we really care about. So we can put any value of x in, but we can't put in x being equal to 2. So we can have all real numbers, not including x being equal to 2. Okay, just to show that I'm not making this up, if you go on your calculator and go menu, graph and table, clear all that. All right, 1 on x minus 2, and graph it, and then just make sure your zoom is just on the normal thing. There we go. We can see that x can be anything except 2. You can see that there's a vertical asymptote there. So that's the implied domain. All right, B. Okay, again, you start to get the picture. You're basically looking for x values that don't work. So here, we're taking the square root of something. So for part B, taking the square root. So x minus 2 has to be greater than or equal to 0, because you can't take the square root of anything that's negative. So if you just solve this, you're just going to get x has to be greater than or equal to 2. So that's pretty much a good answer. If you wanted to write it a bit more formally, say x is an element of 2 to infinity, something like that. Okay. So yeah, the implied domain for that is that. All right, next one, the square root of 25 minus x squared. Okay, again, 25 minus x squared must be greater than or equal to 0. Okay, so let's see if we can solve this as much as we can. Yeah, and remember, when you're solving quadratic inequalities, you need to sketch it. You have to sketch it. Negative x squared plus 25 to be greater than or equal to 0. Literally just swapping it around just to get a feel for what it looks like. I'm hoping you realize that negative x squared is a sad parabola, and it's been shifted up 25. So it's going to go like this and this. Finding x-intercepts, you'll get negative 5. and positive 5. So the question is, where is that greater than 0? So as long as your x values are between negative 5 and positive 5, that whole function is positive. So your answer to this one is a bit trickier, but you're just going to say, as long as x is an element of, all right, from negative 5 to positive 5, yeah, this function will be defined. So let me show you what I mean. If we get the calculator out, we'll see that if we graph that, it will only be defined between negative 5 and positive 5. So let's show you that. Square root of 25 minus x squared. All right, so yeah, it's a semicircle from negative 5 to positive 5. So you can see that the domain obviously works out to be between negative 5 and positive 5. Okay, good stuff. Let's do some of these trickier ones. D, 1 on 2x minus 1. Okay, again, 2x minus 1 cannot equal 0. Okay, so we're just saying what x values can't we have? Okay, if we solve this, we get 2x cannot equal 1, and therefore x cannot equal 1/2. Okay, so we would write our answer not as in what it can't be, but what it can be. X is an element of all real numbers, not including 1/2. Okay, and I guarantee you, if you go and sketch it on your calculator, you'll have a vertical asymptote at x equals 1/2. Okay, part E is similar to part. In fact, it's pretty much exactly the same as part C. It's just 100 rather than 25. So I'm just going to go ahead and write the answer straight away for the exact same reason as part C. X is going to be an element of, not between negative 5 and 5. It's going to be between negative 10 and 10 for the exact same reason as we had over here. Okay, part F. The square root of 4 minus x. Okay, 4 minus x has to be greater than or equal to 0 because we're taking the square root of it. So solving this, negative x has to be greater than or equal to, subtract 4 from both sides. Okay, now we're dividing by a negative number. X has to be less than or equal to, because you've got to flip the sign because we're dividing by a negative number. Less than or equal to positive 4. That should make sense, right? As long as x is less than or equal to 4, yeah, you're not going to get a negative number. So again, let me be super clear. If x is positive 4 here, then the whole thing goes to 0. If x is 5, well, that's greater than 4, and the whole thing's negative. So as long as x is less than or equal to negative 4, less than or equal to 4, you're fine. Because if I put in like 3 here, 4 minus 3 is 1, that's fine. You can take the square root of 1. Even if I put in a negative number, so x less than x equals negative 1. So it's 4 take away negative 1, which would be 5, and you can take the square root of 5. So our final answer for this would be x is an element of, okay, you can have anything from negative infinity, you can have all negative numbers up to 4, and you can include 4. So that would be your answer for that one there. All right, hopefully you found that helpful. Some good questions there. Keep up the hard work.